Hi everyone, it's Crystal Chris here, ready with more questions and some potential answers. Today's question is quite a controversial one, and I've never been one to skirt away from controversy, and in fact I have openly debated this subject very recently. So it's one that I'm willing to step into again, if only briefly at this moment. The subject is the shape of the Earth. Is it a globe or is it flat? I recently participated in a debate at a festival which was recorded, and that recording will be going onto YouTube in the coming days. But I wanted to talk about one specific point which I didn't raise during that debate. I had saved it in reserve for the Q&A section at the end, and I didn't get asked the question, so I didn't share this point. But I wanted to share this with you now and let you ponder it yourself. Now, I am a believer that the Earth is a globe. And during the debate that I had, my opposition, very nice guy, raised lots of points about the flat Earth. But my understanding is the points that were raised were not foundation points. If we were building a house, the points that were raised for the flat Earth, in my mind, were the decoration, the bits that you would put on at the end, the skirting boards, the architrave, and so on. The points I'm interested in are the foundation stones. What's everything else built on? And if we can look at these points and discuss them, well, this other stuff doesn't really matter. So, to my fundamental foundation stone point, what is it? Well, let me show you. A circle. I would like to use the geometry and the shape of a circle to prove that the Earth is a globe. So how am I going to do that? Well, let's talk about it. So, I would open with a question, and that question is, why are there 360 degrees in a circle? It's an interesting question. Is it just an arbitrary, random number that was picked? Or is there a more specific reason? Well, there are multiple reasons. Let me delve into them slightly. 360 is a very, very unique number. It's the lowest number where numbers 1 through 10, apart from number 7, are divisible. So you can divide 360 by the numbers 1 to 6 and 8 to 10. And it's the smallest number that can do that. It's also easy to subdivide. The 360 degrees in a circle were first initiated by the Babylonians. And then the Egyptians took that, and then the Romans and the Greeks and so on afterwards. And so it's ended up with us today. But why did they have 360 degrees? And if we look right back into pre-Babylonians and early days, we actually find that the original circle had 366 degrees. So why is that? And why did they take off those extra 6? Well, let's answer that second point first. If we take 360 degrees, a full circle, and we split it in half, we get 180 degrees. And split that in half again, we get 90, and then 45, and so on. These are good numbers for dividing. If we have a 366 degree circle, half of that is 183 degrees. And then the next point, we're going into fractions. So for counting, it's much easier to have 360, and also with those divisions of the numbers 1 through 10, other than 7, all works with that as well. So you can see why the Babylonians changed it to a 360 degree circle from 366. They also used a base 60 counting system, which is why we have 60 seconds in a minute and 60 minutes in an hour, etc. So, to the first part of that then, why would they have 366 degrees in the original circle? Well, 366 is very close to another number that we know quite well, that being 365. That's the number of days in a year. And here we have the biggest circle that our ancestors could physically participate in and notice, tangibly feel, that being one orbit around the sun. But there's 365 days in a year. So why would they use the number 366? Well, the answer to that is that in one solar orbit around the Sun, the Earth actually spins on its axis 366 times, not 365. But in that orbit around the Sun, one of those axial spins is lost. It goes unnoticed. So how can I demonstrate that? Well, to do that, I'm going to use the Earth and the Moon. The Moon orbits around the Earth. Does the Moon spin on its axis? Many people would say that no, it doesn't, because as we look at it, we see the same face at all times. And so it can't spin on its axis. But let me demonstrate. So, here we have the Earth, and we're looking from above, looking down on the Earth and the Moon. This little dotted area here, facing the Earth, is the Earth-facing disk, what we see. With rotation of the Moon, you can see as it goes around orbiting the Earth, the Moon will spin. It spins once on its axis for one orbit around the Earth. It's tidally locked, which is very unusual, but it does happen in space mechanics. And so because of that, as it goes round one spin around the Earth, it spins once on its axis. But we don't notice that. How do we know for sure that it definitely does? Well, let's imagine it without it spinning on its axis. So, here I have it here. And I'm going to use this little thing as demonstration and my fist. So if this is the Earth, and this is the Moon, and this is the bit that we see all the time, and here we have the Moon going round the Earth. Let's take the Earth out for a minute, and we have the Moon going in a circle, its orbit around the Earth. But we won't have any spin on its axis. It just goes round in a circle around the Earth. We put the Earth back in, we've got the Earth-facing disk. By the time it gets to the other side, it's the wrong side. We would see the back of the Moon, but we don't see the back of the Moon. We always see the same side. So the Moon is actually turning like so. So the same face is always facing Earth. So let's take Earth back out again and have our thing. And as that goes round, and we'll draw the circle in tighter so that for one orbit, it spins once on its axis. And in this diagram here, I can demonstrate that. You can see that without rotation, the dotted line in the area marked X would be facing away from the Earth and on the other side. And we would see the dark side or the far side of the Moon. And when it was at this point or this point, we would see half of the front and half of the back. But we don't. We always see the same side of the Moon. So therefore, we know that as this shows, the Moon is spinning once on its axis for one orbital spin around the Earth. But we don't notice because it's tidally locked, and because either from Earth or even from the Moon, you wouldn't notice that spin is lost because it equates to one orbit around the Earth. That exact same principle is true with the Earth going round the Sun. So actually, it spins on its axis exactly 366 times. Our ancestors took those extra 6 off so that they could make a circle easier to calculate, giving us 360 degrees in our geometry, which we use for all other geometric shapes as well. So the fundamental basics of geometry, of the pattern of a circle and how we would break it down, is literally taken from the biggest circle we can participate in, which is our orbit around the Sun on a globe. So the geometry of the circle, in my opinion, and of course I could be wrong, proves that the Earth is a globe. Have a great day.